Hi, my name is Mariam Hussain and this is my science project on time dilation and its impact on the global positioning system or GPS. Time is a fascinating physical quantity. It's generally believed to flow continuously without stoppage since the beginning of the universe nearly 14 billion years ago. Or is it? Is time independent of any other physical characteristics of the universe? The answer may surprise many. Time is not an immutable physical quantity. It's very much influenced by the happenings around it. Time to you is not the same as time to me. Time on the sun ticks slower than on Earth, and your head is older than your toes. The best anti-aging technique is to live aboard a very fast spaceship. It's true that these effects of time speeding up or slowing down are too small to be observed in our daily life. Hence, I choose to demonstrate a commonly used service by all of us where these effects on time are observed. This service is a global positioning system or service or GPS. Every time we use Google Maps or an equivalent service, the device figures out, using GPS satellite signals, where it's located on the surface of the Earth with extreme precision. But how does the GPS system work? 32 satellites are orbiting at around 20,000 kilometers from the surface of the Earth. Each satellite sends signals which are received by the device, and after some computations based on when the signal originated and when it was received from at least 4 satellites, the device can calculate its own precise coordinates, that is its longitude and latitude. However, to be accurate, the clock on board the satellite should be running at exactly the same speed as the clocks on the Earth. This is because each signal has an embedded time of origin, which is used to compute the distance from the receiver. If the clock on board the satellite is for some reason too fast or too slow, then an error might creep in, resulting in it giving an incorrect reading. Every satellite has an atomic clock, which is a very stable and precise device and has a very minimal error of at most 1 second per 100 million years. Therefore, there can be no error due to the quality of device on board. However, as Einstein postulated in his theory of relativity, the passage of time is influenced by 2 aspects. First, the speed of the body, and secondly, the distance of the body from a very heavy object, like the Earth. Firstly, as speed increases, time slows down, and as the body moves further away from a heavy mass, time speeds up. So, on each satellite, due to it traveling at a very high speed of 3.9 kilometers per second, time slows down by about 7.3 microseconds per day. That is a millionth of a second. However, due to the satellite being 20,000 kilometers above the surface of the Earth, time speeds up due to less gravity. This results in the satellite gaining 45.7 microseconds per day. Combine the effect of these two, kinetic and gravitational time dilation, and a GPS satellite atomic clock falls behind a similar clock on Earth by 38.4 microseconds per day. Now, we may think that 38 millionths of a second is too tiny to matter until we realize the speed of light at which a signal travels, and that is 300 meters every microsecond. So, an error of 38.4 microseconds would mean an error of 11.5 kilometers, and even you would agree that such an error would make GPS an unusable service. In order to compensate for the effect of time dilation, clocks on the satellite are calibrated to operate at a slightly lower frequency than those of Earth's. Time dilation, therefore, is not just an abstract concept, but is very real, and our daily lives would be impacted if we were to ignore it. So, to demonstrate this phenomenon, I have 3 exhibits. The first one is of GPS satellites in orbit. This is a scaled model of the Earth, and there are GPS satellites around it. At any point on Earth, there are at least 4 satellites, minimum, which are in the line of sight and transmitting signals. My second exhibit is one of gravitational time dilation. It's a tall tower with a clock on the top and one on the bottom. Since the clock on the bottom is closer to the center of the earth, it experiences greater gravitational force and hence moves slower than the clock on the top, which moves faster. My third exhibit is to show kinetic time dilation. So this is a moving train which shows that time moves faster on a moving object than on a stationary one. Thank you.